Please, Victor, go ahead.
Yeah, hello everyone. I'm Victor Botev, and I'm the CTO of Iris.Ai. So we are a young startup that was born last summer. We are 4 co-founders, and we have a Finnish link, Maria Ritula, so he's here as well. So I'm going to talk a little bit about future of scientific discovery and what we envision to be the future of science and doing research together with artificial intelligence. So, yeah, a few words about what we think in Iris.Ai, and basically we believe that humans have already discovered the solutions to the world's most pressing problems. But the problem is that these solutions come in the shape of puzzle pieces. And so they come as like research papers, conference presentations, TED Talks, online discussions, and a lot of other scattered points around the world. And maybe they're not at the right time or not at the right place where we need to solve certain problems. So in this abundance of knowledge these days, we need some tools to actually help us navigate and find the right things that we need to solve those problems. So, and as I said, like in the last few years, like the research papers published every year have increased a lot. There are over 3,000 papers published every day. So our human brains are not powerful enough to understand everything happening. I mean, 20 years ago, there were people that were able to understand a lot of things in different areas. Now people are more and more specified in certain niches, but even in those, we still see a lot of new things coming up every day, and we need to stay on top of that if we want to do real research. So we think that there are no tools right now that allow you to navigate the full scope of scientific knowledge and help us connecting the dots between different areas of research and finding new solutions and rediscover old ones that can actually help us solve all the problems that humanity have. So what is the science today? Most of the scientific content is actually made from scientist to scientist. So if you are actually a business person that wants to create a company and solve certain problems, it's hard for you to actually search this science community and to find what you're looking for, because you need to know certain terminologies. The current tools, like the current search tools, work with keywords that not always represent the terminology that you possess in your hands when you're actually searching for stuff. So they also don't show us a full context of research. So for example, from the list that you get from Google Scholar or any other scientific search engine, you get just one piece of the puzzle, but you don't get like the surrounding picture. You don't know what is actually around this paper unless you go and dive deep. But that takes time, of course. So how to approach this problem? Well, basically we are thinking that we need a tool that can read and understand the scientific content to some extent, then use this with a contextual background and form like a landscape of research that we show to the person that is looking for solving a particular problem. That landscape, of course, needs to be explained in an understandable way to the humans as well. I mean, we can form it with an AI, but then we need to present it to the person in a way that they can understand and easily navigate the world of science. So how do we do things, and what do we basically do is in order to be able to read and understand scientific content, we are using certain machine learning techniques and also natural language processing techniques. And first, for example, we start with like pre-processing the text data that we input into our machine learning algorithm. We try to remove certain words that do not give a semantic understanding of the text so that we can train our machine learning algorithms better later. And also like segment the words by their by different parts of speech, like nouns, objects, subjects, because those are the most important part in certain text that can easily bring you to the point where you can more or less grasp what is this text about. Then here is just like a very short example of what like removing stop words means. Basically, removing words like possessive nouns or like at and the is and things like that that do not give any semantic value, basically. Then after that, what we do is we use machine learning techniques as word-to-vec models to represent words as vectors and cluster them together to form like contextual background of the particular words that we find within the text. And we also enlarge that with algorithms such as latent directly allocations to find topics among the whole corpora of documents that are related to a particular topic, and even put even more words to the set of words describing a particular document. So when we do that, we form kind of a landscape of the document. So let's say you input a scientific paper, and then we form like contextual hierarchies of words that represent this particular document. Like in this example, it's from a TED Talk about driver assistance given by Chris Urmson, one of Google's representative, and it kind of forms a simple hierarchy of what this talk is about in some way. So then you can navigate, like you start with driver assistance, then you go to sensing, assistance sensing, pedestrians, accidents, and things like that. So using all those methods, we form something that we call a fingerprint of the input document, something that you can use actually to search for similar documents later. So basically, if you if you run this algorithm through all the scientific content that we have, and build all those fingerprints, you can build a similarity graphs and like cluster papers together, do like mapping. You can create different landscapes where people can navigate from one paper to another, basically related by a topic that is of interest of the current user. And that will allow us also to do things like connecting papers across fields. So for example, in one paper, you can have a method that is used for something, and then let's say in other totally different area, maybe in physics, you find something else that uses exactly the same method but in different way. So in those cases, people can actually see, okay, so this person used this method for that, this person used it for something else, so maybe I can use it for something totally different. And also it kind of removes biases when it comes to like scientific groups and citations that sometimes goes in loops, and you have only papers that are related in a certain way, like a little bit biased. Yes. So our first tool that we released this winter was mainly about TED Talks and showing what basically the tool can do. We are working towards a new version in September, which will work with scientific content, like the abstracts of the papers right now. Then we'll go to the full body of the papers later this year. So basically, you input a TED Talk, it gets the script of the TED Talk, creates the fingerprint of the document, and use that fingerprint to actually search for scientific papers that are related to the topics that we discover in the particular TED Talk. And we form something like a map, like a mind map of this talk, where you can see what was the talk mainly about, and you can browse and like zoom in and out and find other topics that might be of interest to you, and find scientific papers that relate to that particular topic. And we hope that will save time to people, researchers, and business people to actually find the relevant research for solving their most pressing problems. So what our future holds is we want to make science more accessible to people in any ways. We are trying to use as much as possible open access papers as well, so that people can actually read all the things that they find in our maps. We'll put new algorithms into Iris.Ai. So basically, we're building now all these methods that I mentioned. We're building a neural network based on those methods, all of them, and then we'll add a supervised layer to actually do these backpropagation things, because currently everything is like unsupervised. We build a platform for AI trainers where people can go watch TED Talks and annotate them, and then we can use that as a start for our supervised layer. And our research team, we have a small research team developing new approaches for document fingerprint definitions and topic modeling. We are working also together in doing like matching between different papers and building similarity graphs. And we are trying to reformulate the problem of scientific discovery in a way that we can use all the new deep learning methods that have been published. For example, we are thinking of a way to create some kind of a game between robots producing text and robots that actually try to understand the text, and then use reinforcement learning in those type of games to actually make them even more and more advanced in text understanding. So yeah, that's maybe the talk from me. So if you like us, you can visit us on Iris.Ai and check our TED tool. And if you are really interested into see how we do AI training, you can look or register for our AI training program. Yeah, I have a very limited time, but if you have any more technical questions, you can come to me afterwards and we can discuss in more details. Yeah, thank you very much.